Today we're going to be looking at 12.6, which is arithmetic and geometric means, and then finding specific terms. So an arithmetic or a geometric mean means that I give you a starting term and an ending term, and then I tell you how many terms I want in between, and you need to find what those terms in between are. So let's look at an arithmetic mean to start. So, an arithmetic mean, the first example, I'm going to do a part A and a part B. I tell you that the beginning term is negative 14, and I want the entire sequence to end at 40. So that's the beginning term and the last term. Part A, I want us to insert two arithmetic means into that sequence. So that means I want to insert two numbers into that sequence. So here's how I do this. I put negative 14 first. So for part A, our first term is negative 14. And then I want two arithmetic means in between there. So I'm going to put in two blanks because I want to insert two terms. And then we want to end with 40. So remember, an arithmetic sequence means that I'm adding the same number each time. So if I'm adding the same number from negative 14 to get this number, and then from this number to get to my second blank, and then from that second blank to end up at 40, I can find the arithmetic mean by subtracting 40 and negative 14, and then dividing by how many times I want to add that number, which in this case would be 1, 2, 3 times. So let's try it. So 40 minus negative 14, when I subtract a negative, everything turns into a positive. So that's going to give me 54. Now that means that there are 54 terms in between negative 14 and 40, 54 numbers. So if I were to count every single individual number between negative 14 and 40, there would be 54 of them. But I only want to insert two terms, which means I'm adding the same number 1, 2, 3 times. So that number is going to be 54 divided by 3. So let's divide 54 by 3, which gives me 18. So my common difference D is going to be plus positive 18. So from negative 14, I add 18, and that gives me positive 4. Positive 4 plus 18 is going to give me positive 22, and then let's check it. 22 plus 18 is going to end up at 40. So the two arithmetic means are 4 and 22. So we're looking for the numbers that are equally distant in between negative 14 and 40. So let's try it again. Using the same two numbers, the starting number, negative 14, and the ending number, positive 40. This time I want to insert three arithmetic means, so three terms in between the two. So we're going to put in three blanks. Now the process here is the same. I first need to find out how many numbers are in between 40 and negative 14. So that's going to be 40 minus negative 14, which we already did in the previous one, and it comes out to 54. So there's 54 numbers in between negative 14 and 40, but I want to put three numbers in between those. So that means I'll be adding my mean 1, 2, 3, 4 times. So I want these three numbers to be equally distant 4 times through. So that means I'm going to take 54 and I'm going to divide it then by 4. So we find the total number of terms in between, and then we divide by how many times we want to add that specific number. 54 divided by 4 does not go in equally. It gives me 13.5. So that means my common difference D is 13.5. So from each term, I'm going to add 13.5. So negative 14 plus 13.5 gives me negative 0.5. Negative 0.5 plus 13.5 gives me positive 13. And 13.5 plus 13.5 gives me 26.5. Let's check it to make sure we end up at 40. 26.5 plus 13.5 gives me 40 in the end. So our common difference D was 13.5, and that gave me the three terms in between as negative 0.5, 13, and 26.5. So let's do the same idea here, but let's talk about a geometric mean. So a geometric mean is the exact same thing, except we're trying to find R, the number that we multiply by each time. So when I ask for just the geometric mean, the means singular, one. So we're just inserting one term in between each one. So root 2 is my first term. We're just putting one mean in between, so we only have one blank that we're going to fill in. And 8 root 2 is my last term. So that means I'll be multiplying my R 2 times. So let's think about this. If I'm multiplying every single time to find the number of terms, or the number of numbers in between root 2 and 8 root 2, instead of subtracting, because this one's multiplication, I'm going to be dividing. So let's divide 8 root 2 by root 2. So instead of subtracting my last and my first term, I divide my last and my first term. So 8 root 2 divided by 2 reduces down to 8. In an arithmetic mean, after that told us how many numbers were in between. So that 8 tells us how many numbers are in between multiplying. But in order to find the R, I had to divide by how many times I wanted to add the same number. Because I'm multiplying this time, I'm going to take the root of how many times I want to multiply that number. So because I'm multiplying the same number twice, I'm going to end up taking the square root. So the square root of 8 comes out to 2 root 2. So that is not the number that goes in between. 2 root 2 is the number that I multiply by each time. So I'm going to take root 2 and I'm going to multiply by 2 root 2. And then whatever I get, I'm going to multiply that by 2 root 2. And that should give me 8 root 2. Root 2 times 2 root 2. That's going to be 2 times root 2 squared, which also comes out to 2. So that's going to end up being 4. Let me show you that again. Root 2 times 2 root 2 gives me 2 times 1, which is 2. Root 2 times root 2, the roots cancel, so we end up with a 2. So that's going to give me a 4 in between. 4 times 2 root 2, 4 times 2 gives me 8. There's nothing to multiply root 2 by, so it stays on at the end. So we do end up at 8 root 2. Let's do one more like this, and then we will recap finding the means. This next problem wants to find 3 geometric means in between 5 and 80. So 5 is my first term. 3 geometric means in between means I'm going to multiply a number 3 times to get 3 terms in between, and we should end up at 80. So let's first determine how many numbers are in between 80 and 5. So because this is multiplication, we're going to divide. 80 divided by 5 gives me 16. Now that tells me how many numbers are in between 5 and 80 when I'm multiplying. So then I need to break that down into how many times I'm multiplying the same number. I'm going to be multiplying the same number 1, 2, 3, 4 times. So to break down that 16, I'm going to end up taking the 4th root of 16 because I'm multiplying the number 4 times. So I'm undoing that. 4th root of 16, the number that breaks down into 16 4 times comes out to 2. So that's my R. 2 is the number I'm multiplying by each time. So 5 times 2 is going to give me 10. 10 times 2 is going to give me 20. 20 times 2 is going to give me 40. And just to check, 40 times 2 does end up giving me 80. So the steps for both of these, arithmetic and geometric means, are basically the same. We just have to alter the operation depending on what it is we're doing. So arithmetic means mean that I am adding the same number each time. So I subtract the first and the last term to determine how many terms are in between, and then I divide by how many times I'm adding that same number. And that will give me the number that I add each time. With a geometric, to find the number of terms in between, I divide, because we're multiplying in this problem, the first and the last term, and then I take the root of how many times I'm multiplying. So when I was multiplying 4 times, I take the 4th root, and that tells me how many times I will be multiplying. That tells me what number I will be multiplying that many times. So the last few examples that we're going to do, I'm going to give you specific terms, and I'm going to ask you to find what term number or what term they actually are. So let's look at example 4. In example 4, I'm going to give you a sequence, and I want you to determine how many terms are in that sequence. So how many terms does it take to get to negative 380? So here's the sequence: 44, 36, 28, and then we're going to end up at negative 380. I am noticing that to get from 44 to 36, I subtract 8. And if I subtract 8 again from 36, that gives me 28. So I'm thinking that this is going to be an arithmetic sequence. So I'm going to need to use the arithmetic sequence formula, which is an equals d times n minus 1 plus a1. So let's try and figure out what it is we're trying to solve for, and then we can plug in everything we know. The question is, how many terms are in this sequence? So if 44 is n equals 1, 36 is when n equals 2, 28 is when n equals 3, we're trying to figure out what n equals when I get negative 380. So we're trying to solve for n here. What is n when my term is negative 380? So we're going to plug all of that stuff in. Negative 380 is my actual term, so I'm going to plug it in here for an. So negative 380 equals. We know what d is. That's the number that we're adding or subtracting each time. In this case, it's negative 8 times n minus 1, because we don't know what n is, plus a1. a1 was 44. So now all we have to do is solve for n. So let's distribute the 8. That gives me negative 380 equals negative 8n plus 8 plus 44. So negative 380 equals negative 8n 8 plus 44 gives me plus 52. Then I subtract 52 from both sides. So that gives me negative 432 equals negative 8n. Divide both sides by negative 8, so n equals positive 54. So negative 380 is the 54th term in this entire sequence. So let's look at this worded in a different way. Example 5 wants to find the position of negative 29 in the sequence 40, 37, 34, and so on and so on. When it says the position, that's the same as saying find n equals. So what number term is this? 40 is when n equals 1, 37 is when n equals 2, 34 is when n equals 3. So when do I hit negative 29? What n gives me negative 29? So first we have to determine if this sequence is arithmetic or geometric. So take a look at it and see if you guys can decide. So I notice that to get from 40 to 37, I subtract 3. And then when I subtract 3 again, I get 34. So this is an arithmetic sequence. So we're going to use the same formula that we did in the previous one. So an equals d times n minus 1 plus a1. So in this problem, I'm trying to solve for n again. So let's plug in everything we know. an, that's the term that they're giving us, in this case negative 29. So we get negative 29 equals d, which is negative 3, times n minus 1, plus a1, which is 40. So that gives me negative 29 equals negative 3n plus 3 plus 40. So that's negative 29 equals negative 3n plus 43. Subtract 43. So I get negative 72 equals negative 3n. Divide both sides by negative 3, and I get n equals 24. So in this sequence, negative 29 is the 24th term. So when n equals 24, it gives me negative 29 as my term. One more like this and then we are done. So let's look at example 6. I want to find the position. So position means what does n equal, of 768 in the sequence 3, 6, 12, 24, and so on. I notice that to get from 3 to 6, I'm adding 3. But if I do 6 plus 3, that does not give me 12. So that is definitely not an arithmetic sequence. So let's try geometric. 3 times 2 gives me 6. 6 times 2 gives me 12. 12 times 2 gives me 24. So this is a geometric sequence. And the formula for a geometric sequence is an equals a1 times r to the n minus 1. So that's the formula we're going to be using. So let's plug in what we know. an is the actual term that we are looking for, which they give us. It's 768 equals a1, the first term, 3, times r. r is what we're multiplying by every single time. That's 2. To the n minus 1, we are trying to find n. We don't know what it is. So we're going to leave it as n minus 1. So let's try and isolate this 2 to the n minus 1. So in order to get rid of that times 3, we need to divide everything by 3. 768 divided by 3 gives me 256 equals 2 to the power of n minus 1. We have actually done problems like this before. I have this guy equal to an exponent. So in order to get rid of that exponent, we need to try and get the same bases. I can rewrite 256 as a base of 2. 256 is the same as saying 2 to the 8th power. So if 2 to the 8th power equals 2 to the n minus 1, we can drop the bases and we set the exponents equal to each other. So I'm going to do that to over here. So we end up with 8 equals n minus 1. Add 1 to both sides, and n equals 9. So 768 is the 9th term in that geometric sequence. So that is arithmetic and geometric sequences, or means, and then finding specific terms. Your homework is from a worksheet handout that you will be handed in just a second. And I want you to work on that for the rest of the period. And remember that you do have your second quiz tomorrow. So make sure that you are prepared for that. And I will see you guys tomorrow.